Hi everyone, welcome back to example 3. We're going to solve the system of equations by graphing and find out what happens. In this particular scenario, I'm going to show you what happens when things don't work out exactly how you were hoping they would and how to work through that process. So first of all, let's just go ahead and put a standard old XY axis on your graph paper. Y is your vertical axis, X is your horizontal axis, and we have two equations here. We need to find the solution to the system x plus 2y equals -1 and negative x plus y equals 3. I'm going to just try something here because it really doesn't matter what we pick. We could use either xy intercepts as we've been doing all along, or we could convert this to slope-intercept form. Since I've been using xy intercepts this whole time, let's just go ahead and try something else. I have x plus 2y equals -1. So converting this to slope-intercept form, I would have 2y is equal to -x minus 1. And then if I divide everything by 2 on both sides, I get y is equal to -1/2 x minus 1/2. Okay, so this is just math calculations. We can get through that, but what we really need to remember is that this right here is the same equation as what I started with, just in a different form. Now let's go ahead and do the same thing with the second. We have -x plus y equals 3. We bring the x to the other side, so now we have y equals +x plus 3. That one was easy. We just bring the x term to the other side and we're done. Now let's graph them. The blue one, the second equation, is going to be pretty easy. We just count up 3. That's my y-intercept. My rise is +1. My run is +1. Or if you want to count the other direction, that's equivalent to -1 over -1. So down 1 to the left 1 is equivalent to up 1 and to the right 1. So counting these out, we'll have points that are slope of 1, rate of change 1, and we can connect those dots, no problem. There is our graph. Now let's go ahead and graph y equals -1/2 x minus 1/2. And this one might not be as obvious. So just be brave, split your graph intervals in half, and just go ahead and be brave and do it. Count down 1 to the right 2, down 1 to the right 2, up 1 and to the left 2, up 1 and to the left 2. That is an equivalent rate of change. And see how all my dots are in a line. And now I'm connecting the dots. And there is my system of equations graphed. But there is a problem here because the intersection doesn't fall on a nice integer value, which usually freaks people out a little bit. It's in this highlighted unit to the second quadrant, so I know it will be a negative positive value, and I'm just going to make an approximate guess. My approximate guess is -2.5 up, I don't know, maybe 2/3. I'm going to guess that. So 2/3 is 0.666-ish. So that's my guess. Now what we're going to do is find the actual solution. We have to do a little more math to get to the solution that's exact, but trust me, it's worth it because then we'll have the visual to back up our math calculations. We're going to use elimination, And I'm going to rewrite our original system, x plus 2y equals -1, and negative x plus y equals 3. Now I'm going to add the two equations together. Notice that when I add them together, x and negative x add to 0, so I don't have to worry about those guys anymore. Now I have 2y plus y equals 3y, and -1 plus 3 is 2. So if I solve for y by dividing both sides by 3, I get 2/3. Hey, look at that. Y equals 2/3. That's what I guessed it was. I was guessing somewhere right around 2/3. So this is awesome because it backs up my guess. My guess was accurate, and now the math has shown that that's true. Once I have one of these values, I can just use it to find the other unknown, which is the x-coordinate. Now remember, I'm guessing that that's at right around -2.5, 2.5. So I'm going to substitute this y equals 2/3 into the second equation just because it looks easier to calculate. Negative x plus, now remember, in place of the y, I'm going to put the 2/3 equals 3. And now I can solve for x. Negative x equals 3 minus 2/3. Negative x is equal to 2 and 1/3, or you could say 7/3. Either one is accurate. 7/3 is going to be easier to work with. And now remember, since it's negative x, we need to divide both sides by a -1, so that gives us x is equal to -7/3. And if you compare that to -2.5, we see that it is very, very close. So our actual coordinate point here, this coordinate point that we're looking for, the solution to our system, is -7/3, 2/3.